All right, good day, everyone. This is Jason Straight with the Cloud Pass Virtual Group. Our presentation today is running Microsoft SQL Server on Amazon Web Services, and our presenter is Dragos. Before I hand things over to him, I've just got a few announcements to go through regarding the user group. So the first one is that this user group is brought to us by Microsoft. They're a sponsor for the user group, providing us with some resources to help grow the user group or virtual group. If you are not currently a member of, please join the Cloud Pass group out on the Pass website. You can find the group out at cloud.pass.org, and by doing so, you'll get access to the newsletter that I send out about once a week that helps inform people on upcoming webcasts. Speaking of upcoming webcasts, we do have a number of them coming up over the next couple months. We've got some that cover SQL, we've got some Google Cloud Platform, Kubernetes, lots of different areas, Snowflake, pretty much anywhere where the cloud and data merge, we're trying to get presentations to deliver out to folks. If you are interested in presenting, there is an email address that you can send your presentation details to. You can send it to cloud@pass.org, or if you'd like, you can go out to the cloud.pass.org website, and out there click on the call for speakers, and that will get you a form that you can fill out and submit your details. This virtual group is part of a number of virtual groups that that PASS helps to support. Some of these focus on different languages like Global Hebrew and Global Spanish. Some of them focus on different aspects of data platforms like building out hybrid environments, virtualization, or application development. Throughout all these virtual groups, there's a lot of different opportunities to learn. Throughout this session, if you have any questions, please type them into the question panel, and then at the end, or if there is a spot in the midst of the presentation where it makes most sense to ask a question, we'll ask the questions of Dragos and give him a chance to respond. And with that, our session today is running Microsoft SQL Server on Amazon Web Services, and our presenter is Dragos. So let me make him the presenter so he can take over and deliver on his content. So there you go. Dragos, you are now a presenter.
Cool. Thanks a lot, Jason. Can you see my screen?
Yep, it's coming through perfect. Thank you.
Okay, perfect. Thanks a lot, Jason. And thanks a lot, everyone, for joining and taking the time from your day to join this webinar. So as Jason mentioned, my name is Dragos. I'm a solution architect with Amazon Web Services. And today I want to talk to you a little bit about what options you have of running Microsoft SQL Server on AWS. Just to show you quickly the agenda. So I'll have a section where I talk a little bit about the products that we have to run SQL Server, and then I'll go through some of the features and options that you have. So I'll cover stuff like high availability, storage, security, what options you have for backing up and monitoring, and then finally I'll talk a little bit about data migration as well. If you have any questions, feel free to answer them. Usually I like to take time at the end to answer the questions. I'll do so verbally, but I'll also have my email address in the slide. So if for whatever reason you want to send me an email instead of asking, that's also fine with me. So just a little bit about me. I've been with Amazon Web Services for about 4 years now. I'm a solution architect, so I cover Central and Eastern Europe. I'm originally from that part of Europe. I work with small and large customers. I also cover public sector clients, and I also work with partners. I am based in Munich in Germany. We have a pretty big office there, but I travel often to see my clients through Eastern Europe. Before moving into this role, I was a support engineer, again focusing on Microsoft products, and I also did a ProServe engagement as a consultant, also for Amazon Web Services. So if you're unfamiliar with Amazon Web Services, just quickly want to spend 2 minutes talking about them. So we have a very large number of service offerings that cover all of your needs, I would say. So we have over 165 services that cover features such as compute, so the ability to run virtual machines, load balancers, going into networking, so the ability to create a software-defined network, if you will, storage, and of course, databases. As always, time is short, so there's not that much that I can speak to besides our database offerings. But as you can see, we have a large selection of services, and I do invite you to sign up. There's a number of free services that you can use if you haven't done so already. As I mentioned, I'll be talking about databases and specifically about Amazon RDS. So that's our relational database services service. But we also have a number of other databases, such as NoSQL databases, graph in-memory databases, and so forth. Coming back to SQL Server, there's essentially two ways of running SQL Server on AWS. The option on the right is the one where you run essentially the database on a virtual machine using Amazon EC2. So that's our Elastic Compute Cloud service. And this allows you to essentially have a Windows server, it can be 2012, 2016, with SQL Server installed on top of that. There's obviously some advantages to that. So you have the ability to manage the operating system yourself. You have access into the database. So there is a little bit of feeling of comfort of running it on EC2. But then we also have the option of running it as a managed service, and I'll spend my my day-to-day talking a little bit more about Amazon RDS. Being a managed service, it comes with some features that are provided by AWS, such as patching, monitoring, and high availability. And a lot of customers are using RDS because no one really wants to spend time managing a database. They want to do more productive things with their day, right? Obviously, this is a decision that you'll likely evaluate in the beginning, going with a managed service or hosting your own database. As I mentioned, hosting it on virtual machines, which we call instances, gives you some flexibility, but it also comes with more responsibilities, right? So it will have to be you that configures and makes sure the backups are running properly, creates always on availability groups, make sure that the nodes themselves are running healthy, and so forth. And let's not forget also patching. So patching those instances every month with the new updates. We do have services that make that easier for you to do and allows you to automate that. But again, it's something that you would have to consider. And just a few details on what kind of features or versions we support. So with Amazon EC2, so again, the option of hosting it yourself, we support all versions and all editions. With Amazon RDS, we support from SQL 2012 up to 2017. I know a lot of people asked me about 2019, and that was recently made GA, I believe. This is something we're working to get on board RDS as well. I expect by the time I do this presentation early next year, I will have the new version as well. With regards to high availability, Amazon RDS is a managed service, so there's built-in logic that helps you maintain high availability. And I'll speak about that in the next slides. Again, similar to the backups being a managed service, it does come with automated backups. Again, something to take off your mind, and with maintenance as well. So every month after the Windows updates are released, the database and the operating system itself is patched for you, and there's an option to specify when you would like this maintenance window to happen. From a licensing point of view, you have a license included option with both EC2 and RDS. So you can buy a product where you don't have to bring your own license, and this is typically how our users consume the services. But you also have the option of bringing your own licensing, right? So especially if you're an enterprise, you've bought a lot of licenses, you want to still use them while moving to the cloud, there is the option of bringing them over if you have software assurance. Just a little bit about always-on availability groups. So again, it would be something that you have to configure if you're running your database on EC2. Whereas if you're using our managed service, we do have the option of a multi-AZ deployment, and I'll speak about that in a few slides. Amazon RDS is a database that allows is a database service that allows multiple engines. So it's not just Microsoft SQL Server. We also support other commercial databases like Oracle, but also the open source favorite like MySQL and Postgres. And we also have our own database engine that we build, Amazon Aurora, which is compatible with MySQL and then Postgres. So coming back to Amazon RDS, again, it's our managed service for databases, and it allows you to focus on your productivity needs by taking off some of the management tasks. So it manages things like provisioning, so actually creating the database, installing SQL Server, and also patching, right? So again, every month after updates are released, those get automatically installed on your instances. You don't have to do anything about that, and it keeps your database secure. Also, high availability. I'll speak to that in a few seconds, and also monitoring, right? So we provide integration with other monitoring services, either our own, but you can also use third-party services. So what are the things you can configure with SQL Server for Amazon RDS? Well, for starters, you can select how big the instance type and class you want it to be. So we have options going from database with maybe just a few gigs of RAM, 4 processors, up to really big instances like X1, which gives you 3,000 gigs of RAM. You can also choose the engine version and the edition. So we have web, standard, express, enterprise, and you can grow from 2012 to 2017. Also, you can configure the amount of storage you wanna dedicate for the database, and there is an option for the storage to automatically scale if RDS sees that you're running out of free space. You can also configure network connectivity, so you can make the database publicly accessible, or, and this is a best practice, keep it private, right? So you typically don't want your database to be reachable from the internet. You want that to be reachable only from your private subnets, and this is an option you can configure. You also can specify the amount of time to retain the backups. By default, it's 35 days, but you can configure a shorter retention if you need to. Some other options, you can configure an encryption. So you have the ability to encrypt the underlying host when running Amazon RDS. and also whether you want to have a SQL server that is hosted in one availability zone or one data center, or if it's hosted in two data centers. From a technology spec perspective, Amazon RDS is running the exact same SQL Server engine as the commercial offering. So there's nothing that we've done or changed within the product. It also runs under Windows Server. So again, everything that you would expect. There are some limitations that you should be aware of. So there are some things that you cannot run, such as reporting services or integration services, but you can use the database itself as a source for those services. There is also another limit of maximum 100 databases per instance. And this is a big one. You don't have access to the file systems, and there is no sysadmin role or server administrator role. The reason for that is because it's a managed service, so there's some things that we had to limit within the product to allow us to manage it on your behalf, right? So just and there's a link here to our documentation that points out some of these limitations, just so that you're aware of them before you get started. Amazon RDS is a service we continuously improve. So these are just some of the features that we released this year and in the past 9 months or so. The ones that I would especially want to highlight is the Performance Insight one, which we released in March. So I'll have a few slides where I talk about monitoring, and I'll cover this. We've also released support for always-on availability groups for SQL Server 2017. This was in May this year. We also made a few feature releases in November of this year. So November is usually a very busy year for us. So we released support for differential restores and log restores, and also the ability to publish your logs into CloudWatch. This gives you additional flexibility and integration with other services. Okay, so this was a short intro on the Amazon RDS service itself, and I'll speak a little bit about high availability now. So for those that are unfamiliar with how Amazon Web Services structures its infrastructure, we use the concept of a region. So region is usually a geographic concept. For example, we have a region that is on the East Coast, Northern Virginia. A region consists of availability zones. So these are typical data centers. It can be one or more data centers that are spread sufficiently enough such as that an issue in one availability zone would not affect the other availability zone. The latency between them is still small, so you have the ability to create multi-AZ applications, but it does allow you this option of deploying your services in a highly available manner. If you're running your database in a single AZ, so essentially a single data center, there is already a volume replication happening within the AZ. So let's assume you have a RDS database, you've created a volume. Behind the scene, there is actually a replication ongoing for the volume itself. And if for whatever reason this primary volume fails, essentially the database will use a replica. So this happens without any additional cost to you, and again, it happens behind the scenes, right? From a recovery point of view, if you're running a database in a single AZ, recovery can last from minutes up to several hours if there's a AZ-wide outage, right? multi-AZ databases are different. So you still have this replication on the volume level, but besides the database running as a primary node, you have a second node in a different availability zone. So basically in a different data center. The data is replicated synchronously across the AZ. And in case of a failure, the recovery time typically lasts just a few minutes. Usually it's just enough until the DNS record is refreshed. This allows you to have, again, almost instantaneous recovery if the database fails. For SQL 2016 and 17, this replication uses always on, whereas for the older version, it uses the classical database mirroring option to copy the data. It's important to note that this failover is triggered by the SQL Server itself if it sees that the primary node is not available anymore or is not accessible anymore. Just a few key important things. So as I said, you have a primary or a principal node and a secondary node. They sit in different availability zone. And there is a third witness that essentially triggers this failover if needed, that sits in the third availability zone. So again, it can judge whether it's AZ1 or AZ2 that is down, and it triggers the failover as needed. What essentially changes is the DNS endpoint. So when you create an RDS database, it gives you a DNS endpoint that you can connect to. And behind the scenes, this DNS endpoint is being now updated to point to the former secondary database, which now becomes the primary one. Okay. So for always on availability groups, this option is available with 2016 and 2017. It's for Enterprise Edition only. And another important note is that this secondary node, again, sitting in the other availability zone, is not accessible to you. So for example, you cannot use this node to do read operations. This node is completely passive. You do not see it in the console. You just have the option of selecting multi-AZ, and behind the scenes, this synchronous replication happens. And if failover occurs, then the DNS endpoint is updated automatically for you. As I mentioned, this is essentially the process. So you have the primary database instance replicating changes to the secondary one. In the event of a failure, the RDS service changes the DNS endpoint and points to the new database, which now gets promoted as a primary database. Okay. Assuming the secondary database comes back up online shortly, it will now be essentially marked as the secondary node or the slave, and the replication flow is inversed. Okay. This is also very important to note because this is what happens when you also patch the databases. If you're running a multi-AZ setup, right? So in this setup, for example, RDS will first patch the secondary node, right? It will then inverse the traffic, so essentially point to the patched node. Then it will take offline the formerly primary node, patch it, and then enable replication again. And this allows you to have patching happening with, again, near zero downtime. On the storage side, just a few important things. So you can attach or you can define how much storage you want the RDS database to have when you create it. This is something you can also change later on. The maximum storage size is 16 terabytes. And also the maximum IOP size is 32K. On the throughput, there is also a maximum throughput of 500 megabytes per second. And it's important to note that the storage throughput is determined by the database instance class, right? So we have databases which are a good fit for dev test needs. So usually they would be smaller in size. And we also have databases that are fit for production workloads where you have thousands of users accessing them. These are typically bigger instances that allow you to push more throughput through them. One way to excuse me, one way to monitor whether you're having any kind of IO bottleneck is to review the metric called average queue depth. So this is something that you can do within Amazon CloudWatch, which is our monitoring service. Security is a very important topic in Amazon Web Services, and I have discussions around security all the time with my clients. There's three key areas that I want to highlight for SQL Service. So one of them is the ability to restrict access. So we have a service called Identity and Access Management, or IAM, that allows you to control who has access to the API calls that manage the database, right? So for example, you have a new intern, you want to allow him to or her to launch databases, but you might want to restrict deleting databases or deleting a specific database just because you don't want nasty things to happen. So this is something that you can configure using IAM policies. I mentioned that you can have the database as something publicly accessible or not. Again, best practice says that you should not have databases publicly accessible, but this is something that you can configure when you launch the RDS instance, and also later on change it if need to. You can go with the default port of 1433, but you also have the ability to change the listening port to a different port. Again, if you have a public database for a specific reason, it might be a good idea to at least change the port number so it's not a sitting duck for people to try to connect to. A feature that we released a few months ago is the ability to enable auditing logs, audit access logs. So this is a setting that you would enable either at the database level or perhaps for all your databases, and it allows you to capture logs and then perform auditing if needed. The audit logs themselves are retained on the server, so you can quickly access them. You can actually do so from the SQL Management Studio, and they're compressed, so you don't lose a lot of space by enabling this feature. Another important feature that we have with the SQL Server is the ability to do trace, and you see here some code that allows you to do so. So you can create a trace, you can record, any kind of database activities, and then you can read that trace file and determine if everything was in order, if there was anything that happened that wasn't supposed to, and so forth. Encryption is another option that is configurable for the RDS databases. In the backend or behind the scene, it uses our AWS Key Management Service, KMS. There is no additional costs to encrypting the database. From a performance point of view, the impact is minimal, so you wouldn't see any kind of issues if you enable encryption. We support it for all editions, and essentially it enables the entire database and the operating system to be encrypted. This might be something that you need to do as part of your industry regulations. For Enterprise Edition, we also support transparent data encryption, just so you're aware of that as well. With regards to encrypting data in transit, there is a flag that you can configure for databases that forces all client connections to be encrypted. Again, this is something you can set up at a database level, or maybe you want to enable it for all of your databases, and essentially traffic to the database would be encrypted. So instead of seeing some sort of inserts or queries in clear text, these would be encrypted using SSL. Moving over to backup and monitoring. I've mentioned this in the beginning. So Amazon RDS is a managed service, and one of the features that we essentially give out is these automated backups. They are taken daily by the system itself. You can also do more frequent backups if you want to. Transaction logs are backed up every 5 minutes, and the backups themselves are deleted after a specific time that you can also configure, called a retention period. Manual snapshots or manual backups that you take are retained forever, so you can actually have a lot of backups for the database. What is important to note is that restore will always create a new instance, right? So if for whatever reason you have maybe deleted something in a database, you want to go back to an older backup, you would essentially have to create a new instance and then copy over the data as needed, right? Also important to note is that these backups are essentially for all the databases on the instance. So if you have 5, 10, or 20 databases on a RDS instance, you will be backing up all of them, so that's a good thing. You can also do native backup and restore. This is something that you have to be a little bit careful with, not to break the transaction log chain, but it's definitely something that we support and you can do as well. Just a little recommendation from my side. As with anything else, it's good to practice. So it's good that the service gives you these automated backups, but it's also good to do a restore from time to time. See how long it takes to do a restore, because you need to factor that in your DR recovery plans. Okay. Moving over to monitoring, you have a few options. Excuse me. So you can use the SQL Server agent. We recommend running, frequent database checks, just to ensure that your databases do not get corrupted. You don't have any alerting and no possibility to send email using the SQL Server agents, just so you're aware of that. I mentioned CloudWatch. So CloudWatch is our monitoring service. It integrates with most of our services, and it allows you to push logs from SQL Server into CloudWatch, and then do quite fancy stuff, I would say, like automate a backup based on something you see in the logs, or send an email if you see someone doing queries that they should not be doing. An important service that we announced a few months ago is Performance Insights. So This is a feature that allows you to see who is using the database, what users, what kind of queries they're running, and allows you to see, what's happening within your database, why are they wait times, what queries take the most time, and so forth. Also, we do support third-party products as well. So if you're using products such as App Dynamics or SQL Sentry, this is something that you can use with Amazon RDS as well. Moving over to the last topic that I want to cover, which is migration. So you have a number of ways to move your data into AWS. Excuse me. So going maybe from the simplest one, you can actually just export your database and import it using the native backup functionality. You can use BCP, so essentially export to SQL file and then just load them using the command line. Some clients do that as well. It's quick and easy. We do also have a service, a managed service, I would say, that allows you to migrate from on-premise into AWS, called the Database Migration Service, DMS, which I'll speak to in a sec. And finally, you have the AWS Marketplace. So this is a this is a list of third-party vendors or partners that have published software that allows you to move the data. I also suggest looking into the marketplace. There's some really great products that allows you to move your databases. Database migration service is our service that allows you to migrate databases. We support a large number of source and destinations that you can migrate to or from. And another component or another product that we have is the schema conversion tool. So this is a tool that allows you to convert your databases if you're switching database engine. So for example, going from SQL Server to Aurora or maybe Redshift, it helps you with the schema conversion. So DMS, Database Migration Service, allows you to essentially move your data without having any kind of downtime. So, excuse me, you essentially create or start a replication instance. You connect to the source and target databases, so you need to have network connectivity between the two. And then finally, you select the tables and databases that you want to move over. And DMS starts copying over the data. It will create the tables, it will load them with data, and it will keep your databases in sync. And once you're happy that the data is replicated and you're ready to flip over, you essentially just have to stop your database on the customer premise side, let's say, wait for the final replication to happen, and then you can essentially just flip over to the cloud side. Cool. So that was it from me. Thank you so much for joining today's webinar. This is my email address. So if there's any question you don't want to ask today, you don't want it to be read out aloud, that's fine. Just send me an email and I'll be happy to answer. If it's something that I cannot answer myself, then I would go back to my colleagues in the service teams and put you in touch with them if needed. You also have the option of sending me a message on Twitter. And also, if you are interested in learning more about the service itself, below is the web page that should be your starting point, essentially. With that, I'd like to thank you again for joining today's webinar. And if there's any questions, I'm happy to take them.
Yeah, thanks, Dragos. We got one question to start with. So the question is there any service disruption during patching with managed instances?
Cool, good question. Thanks a lot. As I mentioned, if you're running a single lazy database, so just one node, then yes, you would have 5-10 minutes of downtime. You do have the option of configuring when you want those updates to be installed. So usually it would be, a time where you don't have users. If you're running a multi-AZ setup, then that downtime would be almost minimal. I would say less than a minute, because the service would patch the secondary node first, flip over, and then patch the other node. So essentially, it's just the changing of the DNS record you have to be careful with. You don't want to cache that too long, but otherwise you wouldn't have any downtime.
All right, excellent. And this next one is one that I kind of like. Since SQL Agent is available, can you set up SQL native backups?
And the reason why you cannot do that is because you don't have access to the file server. You don't have the permission to actually write to the operating system. If you try to do that, you would get an error.
Okay, great. All right, it doesn't look like we have any more questions, and I'll just wrap up here and give folks another chance to type in questions if they'd like to. But thanks again for presenting today. I always like to get more of different options on how to put SQL Server up in the cloud, and putting it up on AWS is a great option for folks that are looking for alternatives. And if you'd like to come back and speak again in the future on more of this, that'd be great as well.
Yeah, definitely. So I'm quite happy to speak with folks that are interested. I actually have a Microsoft background myself, so I've dabbled with stuff like SQL Server, Exchange, AD. So I know a lot of these concerns that people would have of moving to a cloud setup where they lose maybe some of the tools or controls that they used to have.
Right. All right. Well, thanks again. Thank you everyone for attending. And with that, I'm going to close everything out and wish everyone a great rest of your day. Thank you.
Thanks.